All right, so our last video of this lesson is going to relate translations and reflections. So our question is, how is a composition of reflections, so if you do one reflection followed by another reflection, across parallel lines related to a translation? So in this figure, what we did first, so our first step, step one, was to reflect triangle ABC across the y-axis. So what that rule would look like would be reflect across the y-axis, triangle ABC. The image of that, because remember we start with a pre-image, is triangle A prime, B prime, C prime. So if we look at the picture, here's our y-axis right here. If we take triangle ABC and reflect it across the y-axis, so maybe I'll just look at point C since it's the closest to the y. I'm going to count how many spaces or units to the y-axis. So 1, 2, 3, 4, 5. Then if I go 5 on the other side, 1, 2, 3, 4, 5, that's where C prime is. So this triangle A prime, B prime, C prime is a reflection across the y-axis. So there's one reflection, step one. Step two is now we are going to reflect triangle A prime, B prime, C prime across line M. What that rule would look like would be a reflection, so capital R across line M of triangle A prime, B prime, C prime. So if we look at A prime, B prime, C prime, here is line M. So if we reflect across here, maybe I'll stick with that point C. C prime is 1 unit away from the line. So if I go to 1 unit on the other side, I get this point C with 2 kind of apostrophe looking things. So this is C double prime. This is C prime, this is C double prime. So we can see that triangle ABC, if we reflect it across this line, we get triangle A double prime, B double prime, C double prime. So the image of that reflection would be A double prime, B double prime, C double prime. So what we want to notice is the relationship. So we did a reflection across the y-axis to get here. We reflected across line M to get here. So we just did 2 reflections. The reflection lines are parallel. We've got our y-axis here. We got line M, that's a parallel line. So if you do 2 reflections across parallel lines, then the original pre-image ABC and your resulting image A double prime, B double prime, C double prime actually is just a translation of the original. See how if we just take this and we move it to the right, let's count 1, 2, 3, 4, 5, 6, 7, 8. We move it to the right 8 units, we get the exact same image. So if you're reflecting across 2 parallel lines, that's the same thing as a translation. So let's take note of that. If we have a composition, so if reflect, here's what that looked like. That is a circle that you can't tell very clearly. We use that open circle for compositions. So if we reflect the image we got from reflecting across the y-axis, so we would reflect across the y-axis first, then reflect across the line M. That's the same thing as a translation, and then we did count. The translation, we said it went to the right 8 units, so that is your change in your X is 8. You didn't go up or down at all, so the change in the Y is the same. actually, I missed writing. What are we actually reflecting? Let's see if I can write. Nope. Here we go. So when we write these reflection rules, we do want to say what we are reflecting. So we reflected triangle ABC. That's the same thing as a translation, where we move the image 8 units to the right, 0 units up of the original triangle ABC. Okay. So a translation is a composition of relationships across two parallel lines. Both reflection lines are perpendicular to the line containing a pre-image point and its corresponding image point. So what we're saying there is, if I were to connect C to C prime, the reflection line right here is perpendicular. If I were to connect C prime to C double prime, and here's that reflection line, those are perpendicular. So that's what that is saying. The distance between the pre-image and the image is twice the distance between the two reflection lines. Let me show you what that looks like in this example up here. So the distance between the pre-image and the image. So the pre-image, I'll work with point B. The pre-image is point B. The image is the final resulting image, which is B double prime. So what is that distance between those two? And we came up with that. That was, we knew that we had moved our original image, pre-image 8 units to the right. So what they're saying is that is going to be double the distance between the two reflection lines. So if I go from one reflection line, the y-axis, to the other reflection line, M, and I count that 1, 2, 3, 4, that's 4 units. So if you're reflecting across two reflection lines that are parallel, this will be true every time. Where the distance between the pre-image and the resulting image, it will be double the distance between the two reflection lines.